Everyone, and welcome to the final video in this lesson. In this video, we're going to be exploring limits at infinity and to infinity, and beyond, possibly. All right, so let's get started. All right, so right here we have these values, and we're going to be looking at some limits. So we kind of have been looking at these things here, and we kind of looked a little bit at it in the first video. Okay, so we're going to have these functions 1 over x minus 1 and 1 over x minus 1 squared. All right, so let's kind of look at this. As x approaches 1 for f, which is our left graph, as x approaches 1 from the left side, we're going down. And the way we're going to say that is it's equal, the limit of f of x as x approaches 1 from the left is equal to negative infinity. Now, for clarity, I said in an earlier video, you cannot equal infinity. But what we're going to be doing is we're going to be talking about behavior graphs. And so this is generally accepted because we understand that we are talking about the behavior of the function and it's not saying that the limit of f of x is equal to infinity. And so that's kind of not a shorthand, but an understanding in the mathematical community. But a lot of people will kind of negate that equal sign and say, okay, it's approaching negative infinity. So you can kind of say whichever one that you want. All right, so now as we look here, the limit of f of x as x approaches 1 from the right, it's going up. So that's going to be going up to positive infinity. Now, as we look at the limit of f of x as x approaches 1, our left and right hand limits do not agree with each other. So we're going to say does not exist. Now, let's look over here, DEF, the limit of g of x as x approaches 1 from the left. We see that it's going up to positive infinity, and from the right, also positive infinity. All right, so the limit of g of x as x approaches 1, the left and right hand limits agree. So you're going to see infinity. But remember, again, to clarify, you can see infinity, but you'll also very likely see does not exist because, again, a limit at a value cannot equal infinity. So you're going to see usually, if we leave it the first way, we're going to say, okay, we understand that there is an asymptote for g of x. But you can also write does not exist because the limit does not exist. It does not equal a value. And so that's going to get clarified here a little bit further down. But what we understand is that all of these are vertical asymptotes that we're finding. All right, so that's what we're saying is that if we're going to positive or negative infinity, that we understand that there is a vertical asymptote from these one-sided limits. All right, so moving on, we're going to kind of ignite some of our thoughts from pre-calculus. Okay, so here in part A, we know that we can kind of factor this. Here, f of x equals x squared plus 1 over x plus 1, x minus 1. And since nothing is dividing out, we know that we have some vertical asymptotes at x equals negative 1 and x equals positive 1. All right, so that's what we're doing. Again, igniting some of your lessons from previous years about having vertical asymptotes, see if anything divides out. If nothing divides out, it's wherever your denominator is equal to 0, in this case, negative 1 and positive 1. All right, so moving over to explanation B, we're going to do the exact same thing. We're going to say, all right, factor the numerator and denominator. We get x plus 4, x minus 2, and we get x plus 2, x minus 2. And we see things that divide out, these x minus 2's. So this is going to be x plus 4 over x plus 2. So we have a vertical asymptote at x equal to negative 2. So we understand this from our understanding from pre-calculus in years prior. Okay, so let's look at a couple more examples before we start to get into these limits. All right, so right here, example 3, part A, nothing divides out. So we know pretty immediately we have a vertical asymptote at x equal to positive 1. Okay, so we can see that from our function, our denominator, when is our denominator going to be equal to 0? And the denominator is 0 when x equals 1. All right, so let's look at some trig functions. We can rewrite cotangent of x. So that is going to be cosine of x over sine of x. Nothing divides out, but we want to analyze, all right, when is sine of x equal to 0? Okay. You can be thinking about arc signs or however you want to be thinking about this, but it's whenever we get these vertical asymptotes at x equal to, let's just think about our unit circle. So that is going to be 0, that is going to be pi, that's going to be 2 pi, 3 pi, so on and so forth, from positive infinity to negative infinity pi. Okay, so the way we're going to express this is when x equals any number times pi, any integer by pi. So let's kind of clarify that. N is an integer. All right, so just things that we're going to want to keep in mind about all of our trig values. And remember, our unit circle goes in reverse as well. Now, how does this apply to limits? All right, well, what I want to do here is, without using a calculator, these are going to be non-calc questions, all right? We are going to be looking at some one-sided limits, all right? The limit as x approaches 1 from the left side of 1 over x minus 1, all right? What I want to think is, what is happening? What kind of values approach 1 from the left side? And that's the table I'm going to kind of create. So here is x, and here is 1 over x minus 1. All right, and we're going to get closer and closer to 1 from the left side. All right, so that's pretty close to 1 from the left side, 0.9. All right, and if I plug that in, 1 over 0.9 minus 1, I'm going to get negative 10. Okay, well, what if I get even closer to 1? All right, so I still want to be to the left of 1. So I'm going to say, okay, 0.99. All right. Isn't that a little bit of a step closer to 1? All right. And when I do that, 0.99 minus 1 is 0.01. 1 divided by 0.01 is negative 100. Okay. So let's keep going. Let's get another value that is getting closer and closer to 1 from the left side. So 0. And if you haven't figured out the pattern, just keep going 999. Okay. And we can kind of see a pattern of our function itself. That's going to be negative 1,000. All right. So what are these values approaching? That's the idea of limits. So the limit as x approaches 1 from the left side of 1 over x minus 1, we can see is that this is going to be negative infinity. These values, as we get closer and closer to 1, right? 0.999999999, so on and so forth, we're going to get even greater negative numbers. Okay, so we are approaching negative infinity. And again, it just means that the limit does not exist, but you can kind of see both of them in this case, because we're talking about the behavior, the vertical asymptotes. Now, what happens when we approach 1 from the right side? All right, so let's look at again, make a little table, or you can kind of start to do it in your head a little bit, but x over 1 over x minus 1, and this is my table, and 1 from the right side, that's going to be 1.1, okay? And if I do 1.1 minus 1, I'm going to get 0.1. 1 over 0.1 is going to be 10, all right? Keep going, 1.01, right? It's not going to be the exact same pattern as our table here. It's not going to be 1.11 because then you're getting further away from 1. So 1.01. All right. And so 1.01, that is going to get me 100. And then we're going to get even closer to 1 from the right side, 1.001. And that's going to get me 1,000. And so the pattern limit as x approaches 1 from the right side of 1 over x minus 1 is equal to positive infinity. Okay, so our trick, not really a trick, but what we want to understand is that we have numerical techniques that we can apply here to understand the graphs of these functions. And you've done this in years prior, but what about when these functions change up a lot? You're going to want to apply this concept. As I'm approaching 1 from the left side, I can substitute in values very, very, very close to 1 from the left side and analyze my function with that kind of mentality. Okay, so that is going to conclude this video. You're going to start to work on a lot of these problems and apply a lot of these techniques that you learned in this lesson coming up. So Again, if y'all have any questions, please go ahead and reach out. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.